Good afternoon.
Good afternoon.
This one. So this is week 3 fabrication technique for MEMS-based sensor clinical perspective. This is a problem-solving session. I'm Arpita Biswas, a PhD scholar in electrical engineering from IIT Jodhpur. So this is about me. And in this session, we are going to solve some question, and here is some sample of question. So here we can discuss also if you have anything, if you have any doubt. Okay. So let's start the question. So this is the question number one. Question number one is the given below is the list of the component. First, A the solvent, second the developer, C is the sensitizer, D is the metal nanoparticle, and E is the base material. So which of these are the basic component of photoresist? So option A is A, B, C, D, and E. Option B is A, B, D, and option C is A, C, E, and option D is A, C, D. So take your time and please try to solve the question. And there is no hurry, and please try to give the right answer.
Is it A, B, D? That is the second option.
Mm, Ma'am, you take your time and please go through the question carefully. There is no hurry. You take your time and then try to give the answer.
Solvent developer, sensitizer, metal nanoparticles.
So here is the question is the basic component of photoresist. Yeah, can you please explain about the developer? What do you understand by the word developer? Where
Mm,
it used?
yeah, developer happens to be a chemical which is used to mm, take out the PR.
Okay. So is this the basic component of photoresist?
Okay, it is not for photoresist. It's remove it. So
Yes.
B shouldn't be there, right? Okay, then I
Yes.
think it's the option. First option. No, first option has B. But then the options are like solvent, developer, metal nanoparticles. What do we mean by metal nanoparticles? Should that be there?
Mm, Actually,
It
if
is
we
ACE.
discuss about the metal nanoparticle, nanoparticle it means it is all about the dimension. Okay, so here all you can take the nanoparticle. It mean all direction. It is less than 100 nanometer. So is this the basic component of photoresist?
No,
Then
it.
other option?
I think it has to be A, C, and E. That's
Yes,
option C.
the right option is A, C, and
I
E.
think that was a very direct clue. Otherwise, I wouldn't get. Okay.
Yes, the option C is the right answer.
Yeah.
Okay. So we are moving toward the question number two. Which of the following lithography process can print the smallest feature size? First one is the projection lithography. Second is the contact lithography. Third is the proximity lithography, and fourth one is the direct writing of of patterns.
I would go for contact lithography or the direct writing. Direct writing is not a good idea, so it has to be contact lithography.
Ma'am, can you little bit explain what
Projection
happened in the what happened in contact lithography? Now we can discuss about the like the three photolithography process, like the contact, projection, and proximity. Then you can give the answer. What about the contact lithography? What happened? Where why we go for the proximity or the projection lithography?
projection lithography, in my view, will have a source and a
Mhm.
mask, and your the PR is a little far away. So because of the projection, I think it cannot give very smallest feature size. Is my understanding right there?
Then at first we are going for the contact lithography. What happened in contact lithography?
Contact lithography and direct writing, I have confusion. Like, how exactly is the process? I'm so sorry, my voice is like
Um,
bad.
Okay, okay. Yeah, your voice is clear. And actually, in the next class, I will put some figure of the contact, projection, and proximity. Okay. So if you can see the picture, there is a direct contact between the mask and the where here you can see here is the layer where I have to do the lithography, and this is the mask, right? Mask, and there is almost it is. So there is a direct contact. Okay, so it is in contact lithography. And what happened for proximity? There is a small gap between the mask and the layer where I have to do the lithography, where I have to pattern, generate the pattern. Okay, and what happened in the projection lithography? Like if here you can see, like if there is a lens or mask, so I will show the figure in the next class. If there is a mask, like two optical lanes there is used for smalling for the smallest figures feature size. Okay, so they use a lanes or yes, they use the lanes, so it minimize the feature size in proximity, and there is a small little bit gap in between the mask and the layer where I have to do the lithography. So here is the right option is the projection lithography, because they use the extra lanes to do the smallest feature size, to get the smallest feature size. And in the next class I will show the figure.
I
Okay.
think yeah, that's fine because I think I missed the fact that there will be a lens there. All right.
Yes, there is a lens they had used, and by using this lens, they decreases the feature size. Okay.
Okay.
So contact lithography, there is a direct contact in between the mask and the layer, and the proximity there is a small gap. And in the projection lithography, there in between this mask and the sensing layer, or where we have to do the lithography, there is a lens is present. So it decreases the feature size. So the right option is projection lithography. So we are moving towards the question number 3. Lift-off process is used to fabricate a MEMS device. Which of the statement is correct? First option is by lithography, the inverse pattern of the sacrificial layer is deposited on the substrate. Second, this process uses costly etchants. Third, this process uses the corrosive chemicals. Fourth is the lift-off can give a resolution up to a few nanometers. So please go through the question carefully and then try to give the answer and with explanation.
I think in liftoff there is an inverse pattern of the sacrificial layer, so that sacrificial layer will be removed later. So you have only the structure or the device left.
So which one is the right answer?
I would go for A.
Okay. So here you can see there is a layer. Like if you want to deposit like this type of structure, there is the gold electrode. Okay, and like if we want this type of a structure by lift-off process, so what we will do? Like here we will deposit some sacrificial layer. There is some sacrificial. Yes, these two are the sacrificial layer. Then we will deposit using thermal evaporation system or any PVD system. We will deposit the gold. So here is the gold. Well, here gold will come. This is the gold. And here also the gold will deposit because it is not covered by the sacrificial layer. And also here is the gold will deposit. Okay. So in lift up process, what we will do, we will move this. This is the gold. This is the gold, and this is the gold, and this is the gold. So if we remove this sacrificial layer, sorry, actually this is the opposite of this. So if you want this type of like this only this type of structure, this portion. So what happen if we remove this sacrificial layer, like if there is a oxide is present, if we H with the BOF solution, buffer oxide. So what happen in that case? This sacrificial will remove. This sacrificial will remove, and only and so this metallic layer also remove. So only this portion will remain. Like the next process is that only here is the metal will present. So this is called the lift off process. So the right option is option A. By lithography, the inverse pattern of the sacrificial layer is deposited on the substrate. Because here the sacrificial is here and here is present. But here you can see after the lift-off process, only in the middle portion where the sacrificial layer is not present, is here only the metal layer is deposited. Okay, so the right option is option A. So next we are moving toward the question number 4. Which of the following operation used to align the wafer with the mask in mask aligner? The first option is translation in the horizontal plane. Second is the rotational motion. Third is the linear translation in the vertical direction. And fourth one is the all of the above. So what is the right option?
I think alignment requires all the three, all of these.
Okay. Okay. So the right option is all of this. So next question is mask aligner is used in lithography too. First is coat photoresist on wafer. Second is the align mask and wafer. Third option is the expose the coated photoresist on wafer. And the fourth one is develop a pattern. So the first option is 4 and 1. The second option is 2 and 3. And the third option is 1, 2 and 3. And the fourth option is 4, 2 and 1. So at first go through the question carefully and then try to give the right answer.
Is it 2 and 3? That is a second option. It will
Option
align
5.
and also expose the coated photoresist on the wafer.
Can you, ma'am, please elaborate a little
Only
bit?
okay. Coat. Align the mask and the wafer is the priority. It has to happen like that.
Mhm.
But because that option is not available, so I'm just going ahead with what is the next possibility as expose the coated photoresist on wafer as well. Because wherever there is an alignment mark, that also will get exposed. So I would go for
Okay.
2, 3. That is option 2.
Yes, right option is option 2. Okay, good. So we are moving toward the question number 6. Wage compensation is used in dash exposure mode of lithography. So first is the contact, second is the proximity, third is the projection, and fourth one is the none of the above.
I have no idea what is wedge compensation is like. No, can you please tell me what is wedge compensation in the first place?
Like when you go for the contact contact mode of lithography, in that time there is a like wage compensation is used. So there is a like if there is a direct contact between the uh, mask and the sensing layer, so the defects can happen. So in that case, to avoid this, the wage compensation is used. Okay. Next time from the next class, I will put a figure also. So you will get better idea about the wage compensation and the lithography, all of these three lithography process. I will
Ah,
put the figure. Okay.
okay.
So the right option is the contact printing. Sorry, contact lithography. So this is the question 7. Why split field microscopy is used in mask aligner? So first option is as dimension of the alignment mask are in micrometer, microscope are required to observe those while aligning. The second option is split field microscopy helps to view the alignment mask from both the microscope at the same time and helps to align faster. One and option, sorry, this one will three.
Three. Okay.
Yes, split field microscopy gives the better resolution, and fourth one is the split field microscopy system is easier to install and does not require any optimization. So please try to find the right option. And there is no hurry, take your time and then try to get the answer. We have 2 hours.
No, I was thinking it must be 2 and 3, but that option is not there. So first of all, I mean, split field microscopy helps to view the alignment marks from both the microscopes at the same time and helps to align faster. That's the first option. I mean, the first answer. But which is the other one I have to choose? A split field microscopy gives better resolution. Split field.
Now, can you please a little bit explain what do you understand by the split field microscopy, where it is used, so you can give with the confidence which one is the right answer.
Yeah,
What is the split
I
field
understand
microscopy?
that there are two, fields or two sets of views you get in case of the split field microscopy.
Yes.
So, in my view, second is the option. So, is it two and no? And in any way, I'm finding 2 and 3 are the answer, which is not there in the given option.
Yes, the right option is option like 1 and 2, right?
Okay.
Because no, split field microscopy is used in the mask aligner. So here both we can first the option is coming that we can see the both like the first option as the dimension of the alignment mark are in micrometer. Microscope are used to observe those while the aligning. So if you see the lithography system, so here then the right side you can see the split field microscope is there. So here you can see the like enlarged image of the because the device is in micrometer range. So enlarged image you can see there, and both split field microscopy helps to view the alignment mask from both the microscope at the same time to help the alignment align faster. One, so the first one and second one both are the right option.
Okay.
So next is the question 8. Few aligned masks are given here. Consider the blue mask and the black mask as mask one mask. So like there is a first mask, and then after that you are align the second mask and the wafer respectively. Select the group of masks or show properly aligned mask and the wafer. So which one is the right answer?
Properly aligned one. So even though the first one is the best possible aligned mask, but I think the fifth also is aligned properly. So it has to be 1 and 5.
Okay. So what about the 2, 3, and 4? And what happen if we like if you will use the second one and third one and fourth one?
It
And
is
just tell me where we need this mask aligner. Like there is a wafer is present. We do the first using the first mask. We do the lithography process, and then we want to use the second mask. Like we want the pattern. In that case, we are using this second mask and we do the mask aligning. Okay. So what happened in that case? We want the proper aligning. Why? If we use the second one or third one, what happened in that case?
So if we happen to go for the second, third, or fourth, the alignment for the subsequent layers or the subsequent mask may not be in a proper order or in a proper positioning. So first
Proper.
one is preferred.
Okay, so here you can see the black one is the smaller one, the first mask, and the second one is little bit larger. So why it is like look like this? If we take both the same, then what happen in that case? We can
It's
take
for
now the both is the same dimension, but here you can see the black one is the smaller, the first mask, and after and the second mask where we are aligning, it is little bit larger. So why it is?
it's for the convenience of alignment, because while aligning, if both the aligners are of the same dimension, so the visibility issues may be there. So it's better to have the different sizes but of the same pattern.
Okay, so what if we take the both the same size? So in that case, what can happen?
Visibility, I mean the first one and second one, the visibility, the exact visibility may not be there.
Actually, there can be overlapping type of things we can get. So we are not
Exactly.
properly seeing. Yes.
Yes.
So the right option is 1 and 5. Okay,
Okay.
so option 2. So this is the question number 9. So the following structure is cross-section of an ID structure 1 SI wafer. So here you can see the structures. There is a silicon wafer and then the aluminum like the ID pattern and then the silicon dioxide is used. So what is the process preferred to fabricate the structure? First is the conventional lithography process. Second is the lift-off process and C is the both, and D is the this structure is impossible to fabricate. So please try to give the right answer. At first, see the structure carefully. How we can deposit, like how we can fabricate this type of structure. There is no hurry. You take your time and
Yeah,
then
that's what
try to
I have a
explain.
confusion between lift off and both. So out of, I mean, I'll take the benefit of doubt and put it up as lift off is a good method for this, as it was dealt in the regular course by professor.
Can you a little bit explain?
Mm, explanation wise, no, I have difficulty here. I don't think I'll be able to explain it properly.
A little bit you can explain now why what happened in conventional like can we get this type of structure using the conventional lithography process?
Yeah, in conventional lithography process, the possibility is that oh, this is an IDE. So, mm, if we have to coat the sensing layer of, is it SiO2 a sensing layer, or we are trying to mask something there? Because in VOC fabrication, what professor has discussed, there is a sensing layer which is adeno, but here it is SiO2. So, if your intention
Yes.
is to cover only,
SiO2 is the dielectric, right? There is if you are using the sensing layer, so it must be semiconductive type or metallic type of behavior. Or
exactly.
and here we are they are using in this structure they have used the silicon oxide, which is a dielectric. Or sometimes for passivation layer we can use the like for like mask we can use the SiO2 to cover some portion, right?
Okay. So if we happen to go for the conventional lithography process,
Mhm.
instead of, oh, that's aluminum is a contact pad, right? So
Mhm.
taking out the contact pad may not be possible. So lift off is a good option.
Yes, the right option is the lift up process. So this is the question number 10. Which one of the following statement is true for micromachining? First is the alkaline agent produce the isotropic features after etching of soil silicon. Second is the exon fluoride dry etch of Si produces an isotropic features after etching. Third is the BRF3 dry etch of Si produces the anisotropic features after etching. And fourth one is all of this.
I'm very bad at these chemicals. Not sure what is causing this. The alkaline agents produce isotropic features.
Can you little bit explain about the isotropic or anisotropic process? What happened in that case? So it will, if you have the clear idea about the isotropic and anisotropics, then you can get the answer easily. So what about the isotropic features? Like when it is called anisotropic?
Isotropy and anisotropy is basically for the directional. I mean,
Mhm.
in which particular, I mean, the direction is, it is the etching happening. So,
What happened in isotropic age? Like if you go for the isotropic age, what happened in that case?
uh, so in case of isotropic etching, it moves in the same rate in all the directions
Mhm.
because it will have the same property in all the directions. Whereas anisotropic varies with the direction.
Mm. So this type of structure is produced. Like if there is a silicon, like yes, there is some structure is present, and here we use the mask, like with passivation or something oxide layer is present. So now we want to age it. Like if we go for the like PIMA or KOH, and this is dielectric SiO2, and under the silicon wafer is present. So for silicon etching, we can use the TIMA process for the KOH. Okay. So if we use the like dry isotropic etching process, what happen in that case? What type of structure we will get?
Trench with the proper.
Uh,
uh,
Here is the passivation layer or something, and here like this type of a structure will, right? Because it is all in same rate in all direction, like this type of structure. So undercut is present, okay? Because we don't want this undercut person, we want this type of structure, right? The straight one. But
yeah.
it is isotropic, so in both direction, like in below and the side, both side it will edge. So this is called the undercut. So this
Okay.
is one of the issue of the isotropic age.
Okay.
Undercut. And what happened in anisotropic age? This type of structure is present. If we go for the anisotropic age, what happened in that case? What type of structure we will get?
In an, so sorry. Yeah, in anisotropic etching, it is possible for us to get a proper shape of the trench.
Not proper. Okay, actually, that's why. If you go through the lecture, you can see this type of structure is there. Like not not properly. Actually, this is like this. Here you can see anisotropic age. Now, not it is not straightforward. Like uh, this type of structure you can get for the dry etching process. But for the wet etching process, now, if you go for the anisotropy, in that case, this type of a structure you can get. And there is a angle. Okay, so we will discuss later the angle. Like if here is the angle, like if you take that angle, so here is the angle. So you can see here it is not proper straight. So there is an angle. This type of structure is present, and there is an angle. So I will discuss later what is the value of this angle. So this is called the anisotropic weightage. Okay, this type of structure we will get. So this is the isotropic, and this is the anisotropic. Now we will come to the point. The question, the option. The first alkaline agent produces the isotropic features after etching the silicon. So alkaline agent produces the isotropic or the acidic type of agent. It is discussed in the lecture. Which one produces the isotropic and which one produces the anisotropic. Like there are two types of agent, like alkaline and acidic.
I think it is acidic.
Yes, acidic like do the isotropic. So alkaline do the anisotropic. Okay, so this option is not right. So now go through the second option. Exon fluoride dry age of Si produces an isotropic features after aging. So is this right or wrong?
Three has to be the. I mean, third option should be the third one.
No, not the third one. Exon fluoride is produces an isotopic features because for a dry I have already discussed now when we use the dry edge, so we want this type of structure like this and this. Okay, but in anisotropic, what happened? In anisotropic, this type of features we got like this, and there is some angle is present. So the right option is option B. Exon fluoride produces an isotropic features after aging. Okay, and the BRF3, which is it is also the dry age, and X1 fluoride also the dry age. But X1 fluoride prepared this type of a structure, which is the anisotropic age. And the BRF3 is the dry age which produces an isotropic structure. Isotropic, it's mean here it is this one the isotropic, but it is for the weightage process. Okay, this is the weightage, weight isotropic etching, and this is the anisotropic etching, and here is also the anisotropic, and BRF3 dry age produces the anisotropic. No, the dry age is isotropic, so it is like this in dry age. But in wet age, it is this. Like there is an undercut is present. So the right option is option B. Is this clear?
Yeah.
Anisotropic, isotropic, dry age, and wet age.
Yes.
Okay. So this is the question number 11. What is the main purpose of mask aligner in lithography process? First option is to coat the wafer with photoresist. Second is to expose the wafer to UV light through a mask. The third option is to age the wafer. The fourth option is to bake the wafer.
No, the name of mask aligner itself is not going good here. To coat the wafer with the photoresist. No, it is never done. To expose the wafer to UV light through a mask. Why a mask aligner will do that?
The purpose of mask aligner in the photography process to coat the wafer with photoresist, to expose the wafer to UV light through a mask, or to etch the wafer, or to bake the wafer. Main
Main,
purpose.
main purpose is to align, right? I mean, the mask as well as the wafer. That option is not there. Mask aligner will not etch. It will neither bake the wafer. Why will it be
Not
bake?
the bake the wafer, not
It will
etch
not
the
etch
wafer,
also. And
and
it
not
will
coat
just
the with
coat.
the photoresist. It is also not. So expose the
Because all
main
three are
purpose
not,
is,
I'll have to go for B. That's it.
yes, to expose the wafer to UV light through a mask. Then we come towards the question number 12. What are the three degrees of freedom typically available in a mask aligner for wafer movement? First is the XYZ, second is the XY theta, third one is the XZ and theta, and the DYZ and theta.
It's XY theta B.
Yes. The question number 13 is, what is the role of yellow room in photolithography process? First is to prevent the contamination. Second, to protect the wafer from UV exposure before alignment. Third is to maintain the sterile environment. And fourth option, to enhance the visibility during the process.
B, to protect the wafer from UV exposure.
Yes, the right option is B. And can you little bit explain why not to maintain a sterilized environment or prevent contamination or the option B? Little bit, can you explain?
It is see during alignment. Basically, for the visibility purpose, there may be the UV light, but if it is a yellow room, then this can
Uh,
be.
No, not for the visibility purpose. We use the UV light. So only the exposure, because if we use the photoresist, it is sensitive toward the light. Okay. So when you like coated the wafer with the photoresist, and if for the visibility purpose, if you use the UV light, then it is not good for human health now. So if you for use the for visibility purpose, you use the UV light, it will like if some rays also coming in your body, it will destroy the cell also. So you can't use the UV light for the visibility purpose. Only we use the UV light because we want to expose the UV light on that features, and that portion some because in photoresist also three chemicals are also present, which is light sensitive, and it is chemically its structure is changed. So when you go for the development process, that portion based on this photoresist. Can you explain about the type of photoresist? What type of photoresist is there?
What type of? No, I have no idea.
Type like there are two types of photoresist, like positive and negative photoresist. Have you heard about it?
Yes, yes.
So what happen in case of like in if you use the positive photoresist, what type of structure you will got, and if you use the negative photoresist, what is the difference?
Positive photoresist will harden the exposed part,
Hmm.
and negative photoresist will harden the exposed part. So,
And now I'm giving a structure. Now tell me what type of a structure you will got. Like there is a photoresist, okay? There is a wafer and there is a photo oxide layer, which is the silicon wafer. This is the oxide layer, SiO2. Can you tell me on Si, can we directly deposit the metal layer?
no,
Why?
We
And there
need
is
a
a
high
material.
water layer there.
Yes, but there is some reason now why we deposit some oxide layer there. Like here is a gold is present. In the last lecture, we have also discussed why we do need this dielectric layer in between this metal and Si. Can we deposit directly the Au on the Si? What happened in that case? So you can go through the lecture also. I
Okay.
I have already uploaded it.
I,
And there,
I could not find. Do we have a link for that? Is it?
yes, I think for all the students they have shared because we have to upload the recorded session. And also in my YouTube channel, I have uploaded it, and then I have shared in the logbook. I have shared the recorded lecture because all the lecture now I have taken, I have already uploaded. So if you miss anything, so you can go through from the lecture, and you know it better. So there is a photoregist is present. You can check the mail. I think in by mail they have shared.
Okay.
It's the photoregist. Okay,
Yeah, let me check. I need to go through.
photoregist. Here's the photoregist. Now the mask is like this. Like this one, the like shaded portion, and this one is opaque, and this one is shaded. So tell me, if we use the bright field, like positive photoregist here we have used, and here we use this type of mask. Now tell me what type of structure we will get.
We will have only the middle, that portion. What is?
Mm, okay, see, if here is the photoregist layer is present, only this portion I am showing, okay, not total. Now it is the UV ray is there, and this is positive photoregist. So what happened in that case, which is covered now? That portion is covered, like the first portion is covered, so it will hard. This portion will hard, and the exposed portion becomes softer. For positive photoregist, the exposed this one the exposed portion directly light will come. So this portion will soft. You can also go through the like second week videos, lecture videos,
Okay.
and this one soft, soft. And again the third part will hard. This third part. So if the middle portion for positive photoregist, the exposed portion becomes soft. So what happened in that case? If you go for the development process, this portion will etch out. Okay, so this portion will etch out. Now tell me which portion will remain. Like the in next figure, this type of structure you will get. Like that portion of the photoregist will
Yeah.
remain, and that portion of the photoregist will remain.
It looks like a trench with the.
Yes,
Yeah.
yes. This is the photoregist. And then we go for the etching process. AU etching, we will go for the, you will use the AU gold etchant, and then if you go for the gold etchant, then we will get this type of structure. Like this will cover by the photoregist, and on this portion will etch. Okay, so it will act as a the photoregist act as a mask. So this gold will etch, and then below there is oxide layer, and then silicon layer also present. So after that, we go for the photoresist removal process, like we can use the acetone or something else. So we will finally got this structure. This structure, this is the gold. Because we remove upper side, there is a photoresist is present. We will remove by the acetone, and this is the gold structure. and below is the silicon dioxide, and there is the silicon. So you got your answer right. So what happened in that case? The uh, positive photoresist. So this is the gold. So what happened for negative photoresist? Now tell me.
The opposite of
Opposite,
this
because
part.
this means for the negative photoresist, the exposed portion become harder, so soft portion become harder, and the portion which is covered, this portion becomes softer. So only the portion is harder, the middle portion it will remain, and the other portion will etch out. Okay. So in the for negative, if we use in this mask, if we use the negative photoresist, so we will get the opposite structure. Like in between, there is a metal layer is present, and then oxide layer is present, and then the silicon wafer. Okay. Now it is clear.
Yeah.
Yeah. So first option. So now we can discuss about the answer. Like first option is the prevent the contamination. So for prevent the contamination, we use the clean room. Okay. So not the yellow light. So yellow, where is the light is coming? So it is like the photoresist, which is light sensitive. So second option to protect the wafer from UV exposure. Yes. So this photoresist is very much sensitive towards the light. So if you use the white lights inside of the lithography room, so it can react. So we can't get the proper exposure. Okay, and third option to maintain the sterile environment. So not it is also not, because for maintain the environment we use the clean room. And fourth option to enhance the visibility during the process. No, no, not to enhance. Okay, so the right option is option B. So next is the question number 14. Which of the following is not a step in the photolithography process mentioned in the lecture? First is the cleaning the substrate. Second is the spin coating photoresist. Third is the etching the metal. And fourth one is the electron beam lithography.
Which of the following is not a step in the photolithography? Cleaning is
Repeat the
needed.
question carefully.
Spin coating is needed. Etching the metal electron. No, cleaning the substrate is not a process in photolithography, right?
Hmm.
So A is the answer.
Actually, here is the question that please carefully go through the question. Which of the following is not a step in photolithography process mentioned in the lecture? In lecture, which is not mentioned. If you go through the lecture now, so which process is not like cleaning process? They have discussed. Yes, cleaning process is not the part
Electron,
of the
uh,
photolithography.
correct. Electron beam lithography has not been.
Yes, yes. Electron beam lithography is not discussed in the lecture, and also it is not the part of the photolithography, right? If you go for the photolithography process, so first we have to do the cleaning process. Yes, it is not the part of the photolithography, but at first we have to go for the cleaning process, and it is also mentioned in the lecture video. Okay, hello.
Yeah.
Okay, so the right option is option B. So next is the question number 15. Which of the following describe a key feature of the XY theta stage in a mask aligner? So first is the it hold the UV lamp in place. Second, it is used to manually expose the wafer. Third, it allow the precise movement and alignment of the wafer. And the fourth one, it controls the temperature of the wafer.
C, it allows the precise movement and alignment of the wafer.
Yes. The right option is option C. Next, the question number 16. What is the main reason for using the split field microscope in a mask aligner? The first is to perform the etching. Second option is to view and align the wafer and mask simultaneously. Second, to coat the wafer with photoresist. And third, to expose the wafer to UV light.
I think we discussed this. This has to be a B, to view the and align the wafer and mask simultaneously.
Can you a little bit explain about the other option? Why you are not going for the option A, C, and D? Little bit.
Mask aligner cannot perform etching. Mask aligner or split field microscope in mask aligner cannot coat, or it can neither expose the wafer to the UV light. It's only for the alignment, so it has to be B.
Yes, yes, the right option is B. Can you little bit explain about the etching process when we go for the etching? So here we can cover all the lithography process one by one. When we go for the etching process,
It's only with the mask, PR, and then mask, and then it is etching.
like what type of structure is there? I've already discussed the like after UV expose, then we go for some process and then we go for the etching. So I'm asking about the process. Can you little bit explain about? Can you little bit explain about the photolithography process? What we do one by one?
Yeah,
Little
photolithography.
bit, not that much.
Yeah, you have a layer. Say, let us start from Si, and then comes SiO2, and then you have the layer. Let us say aluminum or gold, or which is the metal to be coated, and after that you have a PR coated on that, and then comes the mask, and then comes the exposure.
Uh, and
That's
also
the
there is a like in between this process, there is the soft bake, hard bake also is present, right? So do you know the need of the soft bake process when we go for the soft bake process and
yes.
when we need the hard bake process?
I needed some more details about it.
Okay, so for soft bake process to remove the moisture, right? When we clean the wafer, like there is a soft bake is required. That you have to give some temperature, and you can go through the second lecture. So I have already discussed it clearly. So we need the soft bake. We remove some moisture from there, and then we like after the photoresist, we heat it for some time, and we should go for some like hard bake process, and we require temperature like around 100 degree centigrade for 10 minutes it is required. So soft bake, it is removing the moisture if it's present in the wafer or surface, and hard bake, it is required to if we coat the photoresist and we like we are, want the stable layer. Okay, so if we not like heat sorry, bake process equipment is we are heating the wafer. So it is like when you go for the development process now, before that we have to go for this heating process, otherwise it will remove easily. But what we want, when you are going for the exposure process, only the exposed portion will etch out, like in the basis of positive or negative photoresist, and remain will stay. So we can use it for the etching process. So in etching process, it will stay there, like the remaining portion will stay there, and it will act as a mask. Okay. So now you can explain. So after the photoresist coating, we will go through some of the baking process, soft bake, hard bake, right? And then we go for the exposure. And after the exposure, what will the process? Hello.
After the exposure, it is the development.
Yes. Then what happened in developing process?
Developing the PR of the softened part will get etched,
Yes.
so your metal is directly exposed for the further process.
Okay. So the softened part will remove, and then which process we will do?
Any etching, maybe
Yes,
DR,
the etching process, like it can be
DR,
dry etching process or wet etching process.
yes.
So in dry etching process and wet etching process, we have already discussed that in wet etching there is the anisotropic and isotropic etching is there. So isotropic both direction is it is etched. So the undercut we can face the undercut issue. And the anisotropic there is a like this type of a structure is present and there is a angle also like in some angle there is a this type of a structure is present in anisotropic. And after the etching, like if we want the gold electrode, after the gold etch, what we will do? Like if we etch out the gold, but on the gold there is some positive photoresist or negative photoresist is there na, as a mask. So which process we will follow? Hello, hello, am I audible? Hello. Hello.
So sorry. I'm so sorry. I had a bad cough. I'm so sorry. Yeah.
Hello.
I'm so sorry. I had a very bad cough. I had to.
Okay, okay. So I'm asking about the next process of the etching. Like there is a photoresist is present na, as a mask, which is covered the AU portion, which we want that this portion will remain. So after the etching process, which process we will follow? Like there is a, this type of a structure is present. There is a photoresist mask is present after the development and etching.
It's a photoresist removal. Correct.
Yes, we will go for the photoresist removal. So how we will remove the photoresist? Which chemical we use? Basically, normally which chemical we use?
Is it KOH?
No, KOH is we use to etch the silicon wafer. At 80 degrees centigrade, we use the KOH solution to remove the SI.
BHF.
So
BHF?
no, BHF we used BHF we used to remove the oxide layer. It is used to remove or etch the oxide layer.
Okay.
So for SiO2 etching, we use the BHF. SiO2.
Okay.
And for KOH and TIMA, one of them is TIMA also used to etch the silicon wafer.
Okay.
TIMA. At
TMA.
room temperature, we use the TIMA. This is the chemical process which we follow to etch the silicon. Silicon. So normally we use the acetone to etch the
Okay. Yeah, yeah, yeah. Okay.
use
Got it.
acetone. Also the other chemical also present, but normally we can use acetone for photoresist. Okay. So what is the right option? Option B is the right option. We only discuss this portion to cover the lecture video portion. If you have any doubt about this lithography process, what happened after which process, so that's why we have discussed. Okay.
Yeah.
So this is the question number 17. What is the purpose of the joystick in a mask aligner system? First, to adjust the UV exposure time. Second, to move the X, Y, and theta stage of the mechanical stage. And the third option is to focus the camera lenses. The fourth option is to turn the UV light and off. So what is the right answer?
I think it has to be B to move X, Y, and theta stages
Yes.
because joystick is
Yes.
always for movement.
Only the for the movement, for the mask aligner, it is only for use for the movement, like X, Y, and theta direction.
Correct.
This is the question number 18. Which source is used to UV exposure in the discussed mask aligner system? First is the UV lamp, second UV LED, then fluorescent light, and halogen lamp. So which one is the right answer?
And the name itself says UV exposure, so it has to be UV lamp. Am I right?
Now, which one?
Name itself says UV exposure, so obviously it has to be UV lamp.
Option?
A.
No. The right option is option B. Here the UV LED is used for the UV exposure and then we use the mask.
What
Okay.
is the
Then
difference? UV LED and
previously,
UV lamp.
actually, UV lamp, previously it is used, but here now is the advanced system people use now. That's why we go for the LED. It will stable also. If you're using the lamp now for the basic in room also, previously they are using the lamp and then we go for the LED. Like it is also more stable and advanced system. That's why they are using the LED.
Okay, because it's a latest technology, but other than
Yes.
that, here it was UV lamp. Okay.
Hmm. Next is the question number 19. What is the significance of the alignment correction feature in the mask aligner? First, it adjusts the UV light intensity. Second, it ensures precise alignment before starting the exposure. Third, it measures the thickness of the photoresist. Fourth, it automatically start the lithography process.
B. It ensures the precise alignment.
Yes. Next is the what is the approximate minimum feature size that the discussed mask aligner system is exposed to achieve? First is the 10 micron, second 5 micron, third is 2 micron, and fourth is the 1 micron. So what is the right answer? What is the approximate minimum feature size that discuss mask aligner system is expected to achieve?
1 micron.
No, it is 5 micron.
Okay.
This is the question number 21. What is the main difference between the bulk micromachining and surface micromachining? So first option is bulk micromachining create a structure on the surface while surface micromachining create a structure inside the substrate. The second option
Yes.
is the bulk micromachining uses the chemical etching while the surface micromachining uses the laser cutting. And third option is bulk micromachining create the structure inside the substrate, while the surface micromachining creates the structure on the surface. And the fourth
See,
option is bulk micromachining is only used for large scale manufacturing.
see.
So the right option is option C. Can you a little bit explain about the bulk micromachining and
Yeah,
surface micro?
bulk micromachining is basically removal process. So the structure will be inside the substrate by removing a part of the substrate. Whereas surface micromachining is above the substrate, you add the layers and create the structure.
Can you little bit give an example like
Micro
in
cantilever.
video also? Yes, in micro cantilever, can you explain about the process and the which one is it? It is the surface or the bulk?
No, cantilever, micro cantilever can be fabricated using both the methods. In case of the surface micro machining, it is above the wafer,
Hmm.
and in case of the bulk micro machining, the cantilever beam actually aligns with the surface of the wafer. The
How
trench is
in
inside.
how
Trench
it
is
can
inside.
be? My question is how it can be bulk micro machining if you the like try to fabricate the cantilever. Like here is the cantilever structure. See carefully. There is a structure is present, and there is a sacrificial layer is present, right? And here you have deposited some metal, like cantilever or metal you have deposited. Now you remove this sacrificial layer. So this type of structure you will get. There is a wafer and there is a structure, right? So now tell me how it can be the which one is it is bulk or surface, and can it be possible it the bulk micro machining?
I didn't get you.
Which process here I have used,
We- uh,
surface or bulk?
I think I missed the explanation there. So
Okay.
the right side one is using surface, and the left side one is using bulk micro machining.
No, no, no. See, surface micro machining, it means on the surface. Here is the wafer, na? See carefully. Here is the wafer. What is the main difference? Here is the wafer is present. Now I have deposited some sacrificial layer. On the sacrificial layer, I have deposited the metal. Here is the wafer. This one is the sacrificial, and the third one is the like the metal. Okay. Now I some etching process. I have removed this sacrificial layer here. So all these things I am doing on the surface of the wafer, like the deposition, the etching, all these things I'm doing the surface. So it is called the surface micromachining. Okay. So when it called bulk micromachining, it is clear, or I will explain a little bit. Hello.
Yeah, I think I have understood this.
Yes, all the thing like deposition, etching, all these things when we are doing in the surface now, in that case it is called the surface micromachining. Now coming to the point when we called it the bulk micromachining. Like here we can see the piezo resistive or piezoelectric pressure sensor. So diaphragm type, like here is the see carefully. Here is the wafer, like the silicon wafer is present. Okay, and on the silicon wafer there is a oxide layer, and after the oxide layer, there is some structure or something is present. Some layer or some structure is present here. But now, how the piezoelectric pressure sensor look like this? The diaphragm type, there is a like pressure sensor, no? So it is giving some force or a pressure. So there is a change in the diaphragm, like so it will change the property of the sensor, like the resistance or the some electrical property. So input is the pressure or the force, and output is change in the form of the electrical property. So this type of structure is present here. Then the oxide layer is present, and on the oxide layer there is a like to measure the electrical property, how much change. If you give some sensing layer also like ZNO or something else, and you have also for the measuring purpose you use some deposit some electrode there, like there is a electrode, all these things. So when you are giving some force or it's change the pressure, like the diaphragm will bend. So it's change its electrical property, and the electrical property will measure from this. So to like from there here to here, you see what is the difference. We etch this silicon, like, and it is also the aspect ratio, like in bulk micro machining, like 1:100, right? 1 is to like the height is 100. So, um, the aspect ratio, the high, the like the length of this greater than the 100 micro, this portion. Can you could you understand this? What is
Yeah.
it? How we are like using the TIMA process or the KWH etching. Here we use the TIMA or KWH to etch the silicon wafer to prepare this type of diaphragm structure. Okay. So now this is called the bulk micro machining. We are going inside of the like inside of the wafer. But here what we have done is this on the surface we deposited some layer, and then we deposited some layer, and again we remove in middle. From middle we remove the sacrificial layer, and only the cantilever is present. So all we are doing on the surface. But now see, here is the silicon wafer, and we all etch the silicon wafer to prepare or fabricate a diaphragm type of a structure. So we are going inside to etching the silicon wafer. We are going inside the device or the like substrate. So this is called the bulk micro machining. Now it is clear what is the main difference between the bulk or the surface.
Yes.
Okay, this is called bulk and this is called surface. This is called surface micro machining. Surface micro machining. Okay. So next we are moving toward the question number 22. What is the aspect ratio in micro machining? So first one is the ratio of lateral to vertical dimension of the etched microscope. Second is the ratio of height to lateral dimension of the etched microscope. Third option is the ratio of width to length of the etched microscope, and fourth one is the ratio of depth to height of the etched microscope. So go through the question carefully and try to give the answer.
Is it depth to the height as D?
No,
It has to be height to the lateral dimension.
it is option B,
Yeah.
height to the lateral dimension.
Yeah.
Aspect ratio means the height will greater, and then this the lateral dimension, like this type of a structure.
But depth to the height cannot
Yes,
happen. Okay.
yes,
Yeah.
this
Got it.
this this lateral dimension and this height. Okay,
Yeah. Yeah.
like the aspect ratio is 100:1. Like the height is 100, then the ratio 100 micro, then it the length like this dimension will 1. This This it is coming in the aspect ratio. Then the next question is question number 23. What is the significance of the etching angle of 54.7 degree in wet anisotropic etching of the silicon? The first option is it defines the angle of the anisotropic etching plane relative to the mass. Second, it is the angle at which the silicon wafer is held during the etching. Third option is determine the speed of etching in different crystal orientation. And the fourth option is it represents the angle of the cavity wall relative to the silicon wafer, silicon surface. So that is the right option. I have already shown the anisotropic age, how the structure will come out, like this type of a structure, right?
Yeah.
This is the anisotropic. So if we this angle, like this angle. So here we if we measure this angle, so this angle, but this angle is 54.7. So what it's mean? Like 54.7 in anisotropic weightage.
Do we say it is with respect to the cavity walls or it is etching angle? It defines the angle of anisotropic etching plane relative to the mask. No, mask, why did mask come into picture there?
Here,
It has to be
here
D.
mass is coming or not? Not, no,
No,
no
no,
required
it
of
has
the
to
any
be D.
mass. Option D is the right option. It represents the angle of the cavity wall relative to the silicon surface. This is the silicon surface, right? Like
Correct.
right here. See, this is the silicon surface. This is the horizontal silicon surface. Then we deposited some metal or something else. Now we want to etch it. So we go for the anisotropic etch. So this is the angle. So from this silicon wafer to this angle, it is 54.7. So it is signifies it represent the angle of the cavity wall. This is the cavity wall and relative to the silicon surface, right? So this is the question number 24. Why it is important to fabricate the VOC sensor for health application? First, to measure the humidity in the air. Second, to detect the specific VOC that may indicate the disease like lung cancer or diabetes. Third, to monitor the concentration of the carbon dioxide in the environment. And the fourth one is to create the device that can work underwater.
That is B to detect the, I mean,
Yes.
specific VOCs. Yeah.
Now we're coming to the question number 25 in micromachining. Which technique was used to create the diaphragm on the sensor? I have already discussed about the diaphragm. What is diaphragm? Why do we use this diaphragm? First on the surface micromachining, second the bulk, third is the electroplating, and fourth one is the chemical vapor deposition. So which one
Bulk,
is the right answer?
bulk micromachining.
Yes. So what about the chemical vapor deposition? Do you know about the chemical vapor deposition?
The chemical vapor deposition cannot create the diaphragm, or rather, it cannot make that structure look like a diaphragm.
Chemical
Only
vapor
deposition.
deposition mean we are depositing some layer, like chemically we reacting some material and we are depositing some material. But when we go for the diaphragm type of structure, we go for the etching process, right? So we are using the bulk micro machining. So this is the question number 26. What material is used to fabricate the heater in the VOC sensor? First is the aluminum, second the nickel, third is the silicon dioxide, and fourth one is the copper.
It is nickel.
Yes, it is nickel. Good. This is the question number 27. Which photolithography technique was mentioned as an alternative due to its ability to avoid affecting the underlying layers? So first option is etching, second is the spin coating, third is the lift off technique, and fourth one is the chemical vapor deposition.
Etching can cause the
Affecting
underlying,
the underlying layer.
yeah. So lift off is the possibility.
Yes.
You
This is the
haven't
question
dropped very
number.
good for this.
This is the question number 28. What is the primary function of the interdigited electrode in VOC sensor? First, to act as a heater. Second is to measure the temperature. Third, to detect the presence of specific gases or VOC. And the fourth one is to protect the sensor from damage.
I think one question I'm very sure is that is C.
Yes. The question number 29. So, what is used as the insulating layer between the heater and the interdigited electrode? First is the silicon, second is the silicon dioxide, third nickel, and D is the aluminum.
Now, any day insulating layer has to be silicon dioxide.
Can you little bit explain about why we use the silicon dioxide as the insulating layer between the heater and the interdigited electrode? What is the need of this layer?
The heater has been, no, it's actually because of the flow of current, it is getting heated. So
Okay.
it cannot directly come in contact with the interdigitated electrodes. So an insulating layer of silicon dioxide, as I
If the heater is coming direct contact to the interdigited electrode, in that case, what will happen?
now, interdigitated electrode is also a metal. So
Mhm.
um, sensing, or rather, it'll not sense, or the sensing may get affected.
Is the sensing is depends on the electrode or it is depends on the material which is the active layer is present there?
It depends upon the active layer as well, the sensing layer.
Yes. Actually, there is a sensing layer is present, like you have already discussed, told that there is a ZNO, if there is a ZNO is present, and on the active layer there is a electrode is present. What is the purpose of this interdigited electrode? To measure the electrical property of this sensing layer when it is come contact to the VOC or some gases. Okay. So what happen in that case? If you use some like heater, so heater is also metal and interdigited electrode also metal. So there can be shorting, right? It can be shorted, like it is coming contact directly coming contact to the electrode, so it is like short. So the current the heating purpose, which is heater is like micro heater is using for the heating purpose, interdigited is electrode is prepared for like to calculate or the measure the any changes of the electrical property on the active layer. So it that's why for like the oppose the shorting, like the two layer shorting, they are use the thin layer of oxide layer. Okay, so there is a nichrome or nickel micro heater is present, then a small layer or a thin layer of oxide is present, then they deposited the interdigited electrode to stop this shorting. Okay, so interdigited electrode is not directly detecting the or sensing the VOC. Actually, when the active layer is coming contact to the VOCs, then it's change its property, like it changes resistance or something else, and then it measure by the electrode. Okay, so that's why the a dielectric layer is present in between this um, um, heater and the interdigited electrode. So this is the question number 30. Which gas is selectively detected in the breath of a person with diabetes using the VOC sensors? First is the nitrogen dioxide, second the acetone, third is the oxygen, and D is the carbon dioxide.
NOx, no, acetone.
Yes, acetone. And this is the last question, question number 31. In the context of the micro machining, what is selectivity? First is the speed with which the etching process progresses. Second is the ability to choose between the different material for etching. Third, the ability of the process to choose between the layer to be removed and interleaving layers. And the option D is the ratio of etching rate to material hardness. So what is the right option?
Selectivity is basically ability to choose between different materials for etching. But in the calculation, we always say that it is a uh, how exactly is the ratio of the etching which was not supposed to be done and the etching which was already done. So obviously, it is the ability to choose between the different materials for etching. B.
No, option B is not the right option. When you tell that selectively age, what is the meaning of it? Or selectively detecting, what is the meaning of it? Why the selective word is used? Like something also present there, but only that particular like layer or something is detecting or something layer is etching. That purpose we use the selectivity word. So
Then it
now
has
tell
to be
me the
C.
right option.
C.
Yes, the right option is option C. Like there is a if we go for the etching process, there is a different type of layer is present. But like if you tell if we are discussing already discussed about the KOH and the TIMA solution. Now tell me there is the photoresist is present, the oxide layer is present, but only TIMA or KOH is selectively etch the silicon. Okay, so selectively, or not it is etch the other of like layer, only it selectively etch the silicon. Also for BOF or BHF solution, it selectively etch the like oxide layer, and acetone it is etch the photoresist. Like so, what is the selectivity here? To ability of the process to choose between the layer to be removed and interleaving layers. Okay, so right option is option C. So now we end the session here. Next session, next Tuesday, 7 to 9 p.m. Okay. So you
Okay.
can go through some I think there is lecture 1 and 2. I have already covered this two session. So you can go through the
Arpita, yeah,
YouTube.
can you tell me like whether the regular sessions
This is
and
the
your sessions
yes,
and
regular session. Professor Hardik J. Pandey is taking now. The weekly
yeah.
you can receive the lecture video. So now we are here. We are discussing some of the question and the answer. And if you have any doubt, also we can discuss here. And you can mail me also. I will discuss in the next lecture.
Okay, how to contact you?
You can directly mail me on this mail ID. Just a minute. I'm just a minute. This is my mail ID. In the chat box, I'm sharing it. And also, you can go through the YouTube videos because this recorded video I will upload in the YouTube, my YouTube channel.
Okay.
And I will also upload it and the log. There is the log sheet. I will upload it. Just a minute. So this is my mail ID. Here also you can like if you want to discuss some portion of the lecture video or something, some question, you can early message mail me and I will discuss in the lecture, next lecture. Have you got the mail ID?
Yeah, yeah. Perfect. Got it.
Okay,
Biswas
okay.
5 at iitj.ac.in.
Yes. Okay, so now here I will end the session. Thank you.
Thank you.